Hey everyone, what's up and welcome. In this video, we're diving deep into the world of data science with Python. Whether you're a complete beginner or have some coding experience, this comprehensive guide will equip you with everything you need to kickstart your data science journey. We'll be covering everything from the fundamentals of Python to building machine learning models, and even touch upon advanced topics like deep learning and time series analysis. So, buckle up, grab your favorite beverage, and let's get started.
All right, let's kick things off with the fundamentals of Python. Don't worry if you're completely new to programming, we'll go through everything step by step. First, we'll understand what variables are and how to work with different data types like numbers, strings, and booleans. Then we'll move on to operators, which allow us to perform calculations and comparisons. Once we have a good grasp of these basics, we'll explore control flow mechanisms like if-else statements and loops. These are essential for controlling the flow of our programs and making decisions based on data. Finally, we'll learn how to write reusable chunks of code called functions, and how to organize our code into modules, which helps in managing larger projects. By the end of this chapter, you'll have a solid foundation in Python, ready to tackle data science tasks.
Now that we have a good understanding of Python basics, let's explore the essential libraries that make Python a powerhouse for data science. We'll start with NumPy, the foundation for numerical computing in Python. NumPy introduces arrays, which are efficient data structures for storing and manipulating large sets of numbers. We'll learn how to perform mathematical operations on arrays, reshape them, and use them for linear algebra tasks. Next up is Pandas, built on top of NumPy. Pandas provides us with data frames, which are like supercharged spreadsheets. We'll use Pandas for loading, cleaning, transforming, and analyzing data. Finally, we'll dive into data visualization with Matplotlib and Seaborn. Matplotlib provides a flexible foundation for creating static, interactive, and animated visualizations. Seaborn, built on top of Matplotlib, makes it even easier to create beautiful and informative statistical graphics.
In the real world, data is often messy and unstructured. Before we can extract meaningful insights, we need to clean, transform, and prepare our data for analysis. This crucial step is known as data manipulation. In this chapter, we'll learn how to load data from various sources like CSV files, Excel spreadsheets, or databases using Pandas. We'll explore techniques for handling missing values, dealing with inconsistent data entries, and converting data into the appropriate format. Further, we'll learn how to merge data from multiple sources, reshape our data sets, and create new features that might be more informative for our analysis. Mastering data manipulation will ensure that our data is in top shape for extracting meaningful insights.
Chapter 4. With our data clean and pre-processed, it's time to dive into exploratory data analysis, or EDA. This is where we start uncovering patterns, relationships, and insights hidden within our data. We'll begin by understanding descriptive statistics, which provide a summary of the main characteristics of our data. Then, we'll leverage the power of Matplotlib and Seaborn to create various types of visualizations like, histograms, scatter plots, box plots, and more. These visualizations will help us identify trends, outliers, and distributions within our data. Additionally, we'll explore correlation analysis, which helps us understand the relationships between different variables in our dataset. By the end of this chapter, you'll be equipped to explore data effectively, generate hypotheses, and communicate your findings through insightful visualizations.
Chapter 5, Machine Learning with Scikit-learn, Building Predictive Models. Machine learning, a subfield of artificial intelligence, empowers computers to learn patterns from data and make predictions without being explicitly programmed. In this chapter, we'll dive into the exciting world of machine learning using Scikit-learn, a powerful and widely used Python library. We'll start with supervised learning, where we have labeled data and train models to predict outcomes for unseen data. We'll explore popular algorithms like linear regression, logistic regression, decision trees, and support vector machines. Then we'll move on to unsupervised learning, where we work with unlabeled data to discover hidden patterns and structures. We'll cover techniques like clustering and dimensionality reduction. Throughout this chapter, we'll emphasize the importance of evaluating and validating our models to ensure they generalize well to new data.
Chapter 6. Advanced Topics. Deep Learning, NLP, and Time Series. Ready to take your data science skills to the next level? In this chapter, we'll explore some advanced topics that are becoming increasingly popular in the field. We'll delve into the world of deep learning, a powerful subfield of machine learning that uses artificial neural networks to learn complex patterns from data. We'll introduce libraries like TensorFlow or PyTorch, which are widely used for building and training deep learning models. Next, we'll touch upon natural language processing, or NLP, a field focused on enabling computers to understand and process human language. We'll explore techniques for tasks like sentiment analysis, text classification, and language translation. Finally, we'll introduce time series analysis, which deals with data collected over time. We'll learn how to analyze trends, seasonality, and forecast future values in time-dependent data.
Chapter 7. Projects and Case Studies. Putting your skills to the test. Now that we've covered a wide range of data science concepts and techniques, it's time to solidify our knowledge by working on real-world projects and case studies. In this chapter, we'll guide you through applying what you've learned to solve practical data science problems. We'll work on projects involving various domains, such as predicting customer churn, classifying images, or analyzing financial data. Additionally, we'll introduce Kaggle, a popular platform for data science competitions, where you can test your skills against other enthusiasts and learn from the best. Participating in Kaggle competitions is a fantastic way to gain practical experience, improve your problem-solving abilities, and showcase your skills to potential employers.